Hello students, today we will study about carbocation, carbanion and free radical. These all are formed by fission of covalent bond. Fission means breaking, cleavage. You are already knowing covalent bond formed by sharing of electron. It is of two types, heterolytic fission and homolytic fission. Let us first deal with heterolytic fission. Let us take one example for it. Suppose we are taking CH3Br. In this compound, bromine is more electronegative than carbon. Between carbon and bromine, this pair of electron is shared. This is covalent bond. Cleavage will take place like this. Bromine is more electronegative. That's why these both electrons are taken by bromine. Bromine will take the shared pair of electron and it will gain negative charge. These two electrons it will take and carbon is giving. That's why it will gain positive charge. So if cleavage takes place like this, that the shared pair of electron is taken by one, that type of cleavage is called heterolytic fission. And this carbon atom having positive charge and 6 electrons in its valence shell. Because it is given these 2 electrons, so 6 electrons, sextet. If anyone is having 8 electrons in its valence shell, it is called octet, 6 electron sextet. So this type of carbon atom is called carbocation. This carbocation was earlier called carbonium ion. Carbocation or carbonium ion. So the carbon atom having positive charge and 6 electron in its valence shell formed by the heterolytic cleavage of covalent bond is called carbocation. Carbocations can be primary, secondary and tertiary. Suppose methyl carbocation, this comes under primary. If we are having ethyl cation, CH2, CH3. Here C is attached to only one C. So this is your primary carbocation. If C is attached to which positive charge is there, just lose one H, then only C is attached to two other carbon atoms. Here C is attached to two other carbon atoms, that's why secondary. And then if C is attached to plus charge 3 other carbon atoms, then it is your tertiary. So if carbocation, carbon to which positive charge is attached to only one C, primary, 2 other C, secondary and 3 other C, tertiary. Carbocations are highly reactive species, unstable because having positive charge, they can form compound which is having extra electrons, highly reactive because it is charged species, but stability increases like this. Tertiary is more stable than secondary is more stable than primary is most reactive because alkyl groups are electron releasing in nature. Here positive charge, shortage of electron, so it will compensate. Alkyl groups are considered as electron releasing in nature. So this is carbocation. Now structure of carbocation, structure of methyl cation. In methyl cation, this C plus is sp2 hybridized and its shape is trigonal, planar shape. Trigonal, this is N, planar shape. So this is C with positive charge. Here one H and here H. In this way its shape, all are sigma bonds. Now about hybridization students, sp, sp2, sp3, sigma pi bond, you will study under the topic hybridization. Here its shape, you can make like this. To understand carbanion, let us take one example. CH3, CH2, Li. This time covalent bond is present between lithium and this carbon. Lithium is less electronegative than carbon. So this time shared pair of electron is taken by carbon. CH3, CH2. It is taking both electron, that's why it will gain negative charge. and lithium is giving these electron, that's why it will gain positive charge. So this time this carbon atom is having extra electrons, lone pair of electrons with negative charge. This is called carbanion. Carbanion. This is also reactive and unstable species because having negative electron, carbanions. Here carbon is sp3 hybridized. In carbocation it was sp2 hybridized. So let us take example of here methyl carbanion. Suppose carbanion is methyl. So this is your sp3 hybridized and its structure is distorted tetrahedral. Okay, now here H3 like this. Now students, again I am telling this is hybridization, which is separate topic which we will study separately. So the reactions which proceeds like this, in which shared pair of electron is taken by one, they are called heterolytic reactions. They are also called ionic reaction, ionic reactions, polar or heteropolar reactions. The reactions which proceeds by heterolytic cleavage are called ionic, polar or heteropolar reactions. Now let us deal with second topic, second type students, that is your homolytic cleavage, B. Homolytic cleavage. Now students, you are already knowing homo means same. If cleavage of covalent bond, breaking of covalent bond takes place like this, that both share pair of electron are X. Here this is shared pair of electron, one taken by each atom. This electron taken by this and this electron taken by this. Then it is called homolytic cleavage. R dot with one electron and X with one electron. So if in this cleavage one electron is taken by both atoms, so this is homolytic cleavage, and these species are called free radicals. These are also very reactive because having one electron which it can share, which it can give or take by anyone, highly unstable reactive species. Now free radicals can also be CH3, suppose CH2, CH3. They can also be primary. Here this carbon atom is attached with only one carbon atom. This is primary. And suppose CH, it is attached to two other C, then it is your secondary. And if it is attached to free radical carbon, if it is attached to three other C, then it is your tertiary. Here C is attached to three other C, it is tertiary. Now here also stability increases like this because these methyl groups are or alkyl groups are electron releasing in nature. Here only one electron, they will compensate. So if more alkyl groups means more stability. So in this way, these cleavage in which one electron is taken by one atom, that is called homolytic cleavage, and the reactions are called non-polar, homopolar or free radical reactions. So thus students, in this way, cleavage of covalent bond. If you like my video, please share and subscribe. Thank you.